Hello and welcome to yet another lecture on control system. Myself Prathita Roy, Assistant Professor of Dr. Sudhir Chandra Engineering College, Electrical Engineering Department. Today we will discuss about the DC and AC tacho generator or the tachometer along with the liquid level control. So let us do with the DC tachometer or tacho generator. The construction of a DC tachometer is similar to a small DC generator. So, if a conception of the DC generator that is generally responsible for producing a generator is generally responsible for producing mechanical energy to the electrical energy. So DC generator or the DC tachometer or tacho generator is similar to the DC generator, small DC generator. So it has two parts. One is called the stator part or the stationary part, another is called the rotor part or the armature part. So let us concentrate on the stator part. As the name implies that the part is remain stationary. It comprises of several permanent magnet poles which produce a magnetic field. So the stator part is generally responsible for producing a magnetic field. So if I draw the stator part of a DC taco generator, you will see that the stator part is like that. So this is a full formation. The stator part is like that. The stationary part is responsible for producing the stator part is like that. And the windings are moved on the stator part, like this one. In that particular way, all the stator part. This is the generally the stator part of the stationary part of an DC rotor. And the poles are mounted in order to produce a magnetic field. Another part is called the rotor or the armature part. A wound rotor is provided with a commutator at the brushes. The output is picked up from the brushes. The rotor shaft is connected mechanically with the shaft of the rotating members whose speed is to be measured. Generally, tachometers are generally responsible to measure the speed of a generator, generally used to measure the speed of the rotor of the machine. So the rotor shaft is connected mechanically with the shaft of the rotating member. Means the rotating part, the shaft is connected with the rotating part, and whose speed has to be measured. So it generates the electrical voltage whose magnitude is proportional to the magnitude of the angular velocity that is input to the shaft, and polarity depends upon the direction of the rotation of the input shaft as shown in the figure 1.A and 1.B. This is the two figures. This is a DC cathode generator when it is rotated at the speed of omega, and here there is the input shaft, and the magnitude is proportional to the magnitude of the angular velocity of the input shaft. So the rotor is a rotating part, and the polarity that is depend upon the direction of rotation of the input shaft. The direction of rotation of the input shaft is rotating in this direction, so means that clockwise direction, and the polarity also depend upon the direction of the rotation, direction of rotation of the input, direction of the rotation of the input part. So what is the principal operation? The operation of DC tachometer is based on the Faraday's law of electromagnetic induction. When a conductor is rotating a magnetic field, we all know that it is generated an voltage according to the Faraday's law of electromagnetic induction, which is directly proportional to the rate of change in flux. So what is the V is the electrical voltage in volts, and phi is the angular displacement in radian of the conductor. When a conductor is wound rotor provided with a commutator and brushes, rotates in the magnetic flux due to the permanent magnet pole, and DC voltage is generated. The conception of the commutator and the brushes are there in order to output, the power that is taken from the brush. This is the output power that is taken from the brushes of the DC voltage, the DC taco generator or the DC motor. So in figure 1.8, it is seen that the terminal A is positive with respect to the terminal B, and the armature rotates in the clockwise direction. Same. If the armature rotation is reversed, then A becomes negative polarized with respect to the B, and it is seen in the figure B. So there is a rotation. So if I draw that particular, this is the rotor part. This, this is the rotor part, and it is seen that it is connected. The output voltage, and it is started rotating in the direction of the shaft is connected. It is started rotating in the clockwise direction with the speed of omega. And this is our generally the rotor part. It is generated by R, the rotor. And the terminal voltage, that is the output voltage that we have obtained, there is a V0 at the terminal A and the B. At A is positive with respect to B depending upon the rotation. If the say the rotation is changed, and now say the rotation is now in this direction, the anti-clockwise, A will become negative and B will become positive. So this is the general conception of rotor. So now the magnitude of the DC voltage can be written as NP NC into N5 by 60 NP into 10 to the power NPP, that is the 10 to the power minus 8 volts, where NP is the number of permanent magnet poles, NC is the number of conductors in armature, NPP is the number of parallel paths between the positive and the negative brushes, N is the angular speed in RPM, while phi is the flux produced by poles, that is in Weber. Since NP, NC and NPP and phi are constant, so it is seen that the output voltage is directly proportional to the speed. So if I draw the tachometer's voltage wave from V0 follows the pattern of the angular speed N of the rotating members as shown in the figure 2.1 and 2.3. So we are dealing with an output voltage from where, if I compare it with the uh, voltage that is generated in a DC machine, it is the generated voltage, that is the V equal to T phi NZ by 60A. So V is directly proportional to the N, the generated voltage, that is the output voltage. So if I draw a typical graph of speed versus time, and also the speed versus output voltage V0 with respect to time. So the typical graph that is obtained is seen that there is this graph will be like that in nature. And if I draw the graph of time t versus V0, so we will see the graph, the spike of the graph is like that, same as what was in n versus t. So this is the general construction. And depending upon the rotation, the polarity of the output voltage is also changing. So this is generally the speed versus time graph and the output voltage versus time graph. in case of the DC tachometer or tachogenerator. This is tachometer or a tachogenerator. If I got a discussion about the DC tachometer or the tachogenerator, it is seen that DC tachometer or tachogenerator is small as same as the DC generator, small DC generator where the input is mechanical and output is electrical, where we generally DC tachometers are used in order to measure the speed. Means with the DC motor, that is the two part, one is stator and the rotor part, where the stator part is the poles are mounted on that, which is generally responsible for producing the flux, where the rotor part is the rotating one. According to the Faraday's law of electromagnetic induction, a flux will be generated which is directly proportional to the between the poles. Is when the rotors start rotating, there will be gradual cut of the flux, and a voltage will induce. That is according to the Faraday's law of electromagnetic induction. That voltage is E is directly proportional to the rate of change in flux. E is directly proportional to the rate of change in flux, that is d phi by dt. This is the Faraday's law of electromagnetic induction that is known to us. And again, we will see that the speed of that particular motor or say any object which is connected with the shaft of that rotor of the DC generator, which is generally connected to the shaft of the rotor of the DC generator, that is uh, which that speed have to be measured with the help of tachometer or the DC tacho generator, and the speed is directly proportional to the voltage that is induced in the tacho generator, and the corresponding speed versus time graph and the output voltage versus time graph is also shown in this figure. So the construction is same as like the construction of a DC small DC generator. So now we will concentrate on the AC tacho generator. So AC tachometers of the tacho generators are construction. It is having a two phases of the two. It is similar to an AC servo motor, where it is constructed as a two parts. One is another is known as stator part, another is known as rotor or the armature part. One is the stator part, and another is the rotor or the armature part. So the stator part, that is consists of two coils that are oriented at a right angle to each other in space coordinature. One coil is called the reference coil and other called the coordinator coil. Two windings are excited by a voltage having a 90-degree phase displacement. So if I see this, there are two windings are separated. So I think if I so in order to produce the phase displacement, means we all know we have to create a phase displacement in order to produce in the rotating magnetic field. So they are in space, they are 90-degree apart from each other. So that is seen that the two windings, they are 90-degree apart from the each other, and if they are fed back with the help of a voltage source, if they are fed back in order to create the temporal phase displacement between that two, so what we have done, so we are, this is known as the reference coil. This coil is known as the reference coil, and this coil is generally known as quadrature coil. And it is seen that quadrature coil. So it is seen that both the coils are separated by an angle 90-degree in space. So we are created a special phase displacement. Now in order to produce the magnetic rotating magnetic field, we have to give a balanced supply, and along with that we have to produce an angular phase displacement. So let us, this portion is excited by an voltage V1, an output that we have obtained from that particular voltage, that is the V0. From there we are obtaining the, and those coils are say, uh, we have just drawn the coils first. So this is another coil. So we are taking an output V0 from that particular coil, the quadrature coil. So one is known as reference coil, and if I draw the axes of those coils, this is the axis of that particular coil, and this is the axis of that. This axis, first one is the axis of the reference coil, second one is the quadrature coil, and they are 90 degree apart from each other. So in order to produce a voltage source, that we will discuss that how the schematic diagram of an AC tacho. This is the armature winding, that is the arrangement of the winding. This is the arrangement of an winding of an AC tacho generator. So we are now arrangement of windings. A winding are arranged in order to produce a rotating magnetic field. In order to produce the rotating magnetic field, in order to produce the rotating field, how the arrangement of the windings are done. Now, how we are dealing with the schematic diagram of an AC tacho. We are doing with the schematic diagram of AC tachometer. So what is the schematic diagram of AC tachometer? So in order to find the schematic diagram of AC tachometer, this is our reference coil. Where a reference voltage that will be produced, and the voltage that will be produced, they are having a 90 degree phase displacement. So here the reference voltage VR is producing, where they are, it is known as Vm sin omega t. And where another is the 90 degree quadrature, that the management of the winding that we have seen, that is the V0, that is called the quadrature axis, where the output voltage are 90 degree phase displacement to each other. So here it will be given as Vm, the quadrature voltage, that is Vq, can be written as Vm sin omega t, Vn sin omega t plus pi by 2. It is 90 degree to each other that we have set. We have seen that how the arrangement is done. So this is called the rotor part, which is the rotating part of that particular arrangement, and with which the shaft is connected, and on the shaft that the measuring instrument or the measuring equipment, or say the load or the motor, or that will be connected, that is called the mechanical load that is connected. And if the rotor start rotating, this mechanical load start rotating, and with the help of the tachometer we have to measure the we have to measure this is called the load, the mechanical load. The speed of that load or the speed can be measured with the, as the rotor start rotating and the load is connected with the shaft, the load is also rotating and the speed can be measured with the help of tachometer. This is called the mechanical load, and this is the shaft, the mechanical shaft one that is known to us, and this is the arrangement of AC tachometer. The load is connected with the shaft and with the help, as the rotor start rotating, because there is a phase displacement and the temporal displacement between the two voltages, that is the reference voltage and the quadrature voltage that is applied. So that means which instance which is producing a magnetic field according to the Faraday's law of electromagnetic induction. At the rotor start rotating, it will gradually cut the flux that is generated between the, how the flux is produced by 90-degree phase displacement in space and also in the time domain, that is the temporal, to produce a flux. As the flux is produced and the rotor starts rotating, it will gradually cut the flux. And if a flux is gradually cut according to the Faraday's law of electromagnetic induction, a flux will be generated, a voltage will be generated, that is E proportional to d phi by dt. This voltage which in turns produce a current to the rotor, as rotors are short circuited at the inverse, and the mechanical shaft is connected to the rotor, and the load is connected to that shaft. As the rotor starts rotating, the mechanical load also starts rotating. With the help of the AC tachometer, we can easily measure the speed of the shaft, rotating speed of the shaft. So the rotor part is it is consists of a thin aluminum or copper cup which rotates in the air gap between the fixed magnetic structure. We also known to the conception of the air gap. Inertia of the rotor is very low and the rotor is wound with highly conducting material to provide an uniform short circuit path. So how the operation is done? A sinusoidal rated voltage is applied to the reference winding. Since the rotor is coupled mechanically to an object whose speed is to be measured, that I have told, the rotor rotates with the same speed as the object. The voltage of the quadrature coil is produced with proportional to the speed of the rotor. Mathematically, it can be represented as E0 equal to Kt into ddt of phi t, that we have already told. E0 is the output voltage in volt, theta is the angular displacement of the rotor in radian, and Kt is the tachometer constant, that is volt per rad per second, that we have already known. This is generally known to us. So means we have to measure the speed of the object, same in case of the DC and the AC, but the arrangement for the DC is that only the DC generator, small DC generator, where the voltage is applied and the rotor is rotated, which in turn measure this. And on the shaft of the rotor, the object is connected and the speed is measured with the help of DC tachogenerator. But in case of the AC tachogenerator, the difference is that in order to produce the flux, there is management of the winding is shown, that the reference of the quadrature axis is in space. There is a spatial displacement is the 90-degree, and the temporal displacement is the sine omega t, is Vn sine omega t and Vn sine omega t plus 90-degree. So in order to produce the uniform, and this Vm means both are Vms, the magnitude of the peak voltage is same, that is called a uniform, a balance supply is provided, and they will create an phase displacement in the time domain, that is sine omega t plus pi by 2 90-degree, in order to produce the magnetic field. So this magnetic field, which referred as law of electromagnetic induction, at the rotor start rotates, it will induce a voltage on the rotor, which is another current to flow to the short circuited rotor bars that we have already seen. And another portion is that the shaft is connected with the rotor, which also rotated, and the mechanical load or the object, that the speed of that object have to be measured with the help of the tachometer, which is same on the speed of the rotor, so that the speed can easily be measured with the help of that particular. If I know the output voltage, you can easily measure the speed. The speed is so the output voltage, that is always can be proportional. So the what is the output voltage? That is output voltage is directly proportional to the speed of the rotor. So if I know the output voltage, if we measure the output voltage, you can easily find the speed. So another portion that we will discuss today is the liquid level control. So two tank level system may be referred to as a two first order tank level system connected in series. That those two tanks are connected in series. Depending upon the piping arrangement, the two tank levels can be classified into non-interacting system and the interacting system. So let us see the non-interacting system. This is the figure of non-interacting system. So here the outflow of the tank 1 is discharges directly to the atmosphere before falling into the tank. That is the outflow from the tank 1 is directly discharged into the atmosphere before falling into the tank. 2. Liquid flow through the R1 and R2 depends on the respective levels of the tanks T1 and T2. But the variation in the height, that is the H2, there's a variation in the height, that is the H2 in the tank, has no effect on the variation occurring in the tank 1. So this is called the non-interacting, means there is no interaction between the two tanks because variation of the H2 has no effect on the variation occurring in the tank 1. So assumption is that liquid density should be remain the same with the two tanks, and the tanks have two uniform cross-sectional area. So writing the mass balance around the each tank. So mass flow in minus mass flow out equal to rate of accumulation of the mass in the tank. So that is the, for tank 1 it is Qi minus Q1 equal to A1 equal to ddt of H1. There is a rate of accumulation in the tank 2. For the tank 2 it is Q1 minus Q2 equal to A2 into ddt of H2. Again, from the flow head relationship, that is Q1 equal to H1 by R1, that is known to us, and Q2 will be H2 by R2. Okay. So this is generally the known as the non-interacting system. So the non-interacting system can be given as for the flow of mass or the liquid, that can easily be given as. So first we will concentrate on the non-interacting system. That the basic principle that just I have told. Now I have told about the non-interacting system of the liquid level control. We are dealing with the liquid level control. This is our liquid level controller. Liquid. We are dealing with the liquid level of the liquid can be controlled. We are dealing with liquid level control. So there is an conception of non-interacting section, that is the height of the second tank does not depend on the height of the first tank. So that is the main concern. So that is the Q2, that is the Q1 that is coming to the tank 1. This is the R1, the resistance, that is the arrow R1. For tank 2 it is the R2. So again that is the height is denoted by the height of the liquid, here it is denoted by the H1.
and height of the liquid 2, that is denoted by the H2. H2, that is the height, and this is the Q1, and there is the input is called the QIT, input of the water level, input of the water, or input of the any liquid, but assumption is the liquid density will remain the same around the should remain the same, and the tanks having both the tanks having a uniform cross sectional area. Now for tank 1 we can write the mass flow in. There's a mass balance for tank 1. We can write this tank 1, and this is tank 2. So for tank 1 we can write the mass balance equation. There is the inflow rate, mass inflow rate, mass flow in minus mass flow out equal to rate of accumulation of mass in the tank, that is Qi, that is in, and out is the Q1 equal to K1 ddt of H1, that is the height of the tank 1, and for tank 2 it is written as Q1 is the inflow minus mass flow out, that is the Q2, and instant, that is written as A2 into ddt of H2, ddt of H2. So for the flow head relationship, now from the flow head relationship, there is a flow head with relationship. You can easily write from the flow head relationship. You can easily write that from flow head relationship you can easily write Q1, that is H1 by R1, H1 by R1, and Q2 equal to H2 by R2. This is called the non-interacting system. Non-interacting because the liquid flow through the R1 and R2 depends on the respective liquid levels in the tank 1 and tank 2, but the variation in H2, that is the height in the tank 2, has no effect on the variation occurring in the tank 1. So it is named as non-interacting.
This is the general
Conception of the non-interacting liquid level control. Now, our second part is interacting system. So we have seen that the interacting system, the two tank levels are shown in the figure. So tank, that is Q2, the QIT, that is input in the tank 1, and that is the tank 2. So the above system is said that to be interacting because the flow through the R1 depends on the, why it is called, again I am repeating, there's the flow through that is doesn't depend on the H2. Any variation in the H2 means doesn't depend on the variation of the H1, but means that the variation in the H2 in the tank has no effect on the variation occurring in the tank H1. But here it is seen that the variation is interacting because the flow through the R1 is depends between the difference between the how liquid will flow through the R1. It is totally dependent upon the difference between the H1, the height of the tank 1, and the height of the tank too. So the assumption is that density of the liquid remain constant and the cross-sectional area of the tank 1 and tank 2 should be uniform. So again, the water balance equation, that is the mass flow in minus mass flow out equal to rate of accumulation of the mass in the tank, that is P into QIT minus P into Q1T equal to ddt of, there's the density rho into rho into ddt of rho into AH1T. So if the density and the QP into Q1T minus QIT minus Q1T equal to A into ddt of H1T. So again for the tank 2 it will be Q1T minus Q2T equal to ddt of A2 into ddt of H2T. So water flow rate relationship Q1 will be H1T minus H2T, H1T minus H2T by R1, and where the tank 2 it will be H2T by R2. So it is seen that the rate of flow through the R1 is depends upon the difference between H1T and the H2T. So that is the known as interacting system. So the same as we have done in the previous race, only the change is that uh, from the non-interacting to interacting is that it is depend upon the flow rate of H1 and H2. That is why the flow rate relationship became H1T minus H2T by R1, where in case of the non-interacting it will be only the, in case of the non-interacting it will only the H1 by R1, but in case of the interacting it is in that H1T minus H2T by R1. So this is known as interacting system, where the flow through the R1 depends on the difference between H1T and the H2T. So today we have learned about the tachometers, tachogenerators, AC and the DC tachogenerators and the tachometers, along with the liquid level control of the non-interacting system and the interacting system. Today we have learned about the non-interacting system and the liquid level control, that is the non-interacting system and the interacting system. Thank you.